This is Lecture 2 of CS 435. In Lecture 1 I talked about the two different groups that I worked in at Motorola, and that first group I worked in, I said our product was really just a total failure, complete disaster. And in that first lecture I attributed most of the problems to the lack of this thing called a process. We had no process in that first group. So today we're going to talk quite a bit about, well, what is a process and why are processes important. So a software process is simply a set of rules and tools used to create a piece of software. The process identifies what steps need to be followed, in what order they should be performed in, and the outputs, in addition to working code of course, that are required when developing software. So usually each phase in the software development lifecycle results in some document being produced. Okay, and in the implementation phase, that is usually code. But in all the other phases, requirements, specification, design, testing, okay, all of those phases typically have some document or some work product that comes at the end of that phase. So a rigorous process implies really a great deal of paperwork that the developers have to do, and the paperwork is all geared towards enhancing communication. So communication really is one of the hardest things to manage in a large project. So there are many different competing processes. There are many software gurus out there that have their own processes. So they basically are not necessarily responsible for coming up with all of the things not inventing all of the things that you do in a process, but they've decided that in their experience, if you do these series of things, that's going to create the best software product. So one process, for example, might require that you do a formal design document after the design phase. Okay, and in addition, we should review that document. There should be a peer review of the document. And in this particular process, we need some sort of electronic defect tracking system where summaries are available 24 hours a day at any location. Okay, and another part of the process might be that there must be a software quality assurance team that overlooks the output of each of the phases. Okay, so like I mentioned last time, I worked in these two different groups, and in the first group was very small, so there were about 15 people, and at any one time, about 2 or 3 people were dedicated totally to the software. And there was very little software process, meaning there weren't any rules about what needed to be done. So we knew there was a deadline where we had to have our code complete, but that's about the only constraint that we had. It was us, the software developers, that decided what needed to be produced, not our managers, which is really how it should have been. Now, it was kind of fun or exciting to be completely in charge and completely responsible for everything related to software. However, ultimately that project was a failure. It cost way more than expected. It took way longer than it was expected to take, and there was less functionality than was expected. So the classic failed project, or in that 50% group where it's not a total failure, but this was a really bad group. And like I said last time, the primary reason for the failure was we had no formal process. And when I think back, I believe when I left, they were continuing to work on this project, and I really would not like to have been the person who replaced me, because a lot of the knowledge that I built up in my time there, it walked out the door with me. It was in my head. Nowhere did I write it down or have it documented somewhere. Okay, then I moved to this other group, the cell phone group, and this was a very large organization. There were thousands of engineers all over the world, and this group was very process intensive. meaning there were procedures in place for every aspect of the development process. I had no choice about what needed to be produced. I was given this process manual the first day, and I had to adhere to it. Okay, so that was part of my job. Was at the end of this phase we had to create this document, and at the end of this particular phase we had to do X, Y, or Z. So it wasn't up to me anymore. There was actually a process in place. So inside this process folder that they gave me, there were things like document templates, coding standards, build how to achieve the build process. We had the simulation tool that we were supposed to use and use it for testing. Okay, and also what was really important for me was not only on the first day did they give me that big thick notebook of the process, but they signed me up for a course right away that went over in detail what this process was all about. So I guess you have to ask yourself, well, is it more fun to be in a process-heavy group? At first, I'd say not really, because I'm a big fan of writing code. I don't like to write documents. There's definitely more writing of documentation in a process-heavy group. In that first group, I didn't write many documents at all. So I showed you last time a couple of the documents we created, but they were really they were not great documents. However, when there is a formal process, you get to spend most of your time working on solving problems. In that first group, when there was no process, we spent a lot of time putting out fires instead of trying to achieve our goals. So we spent long hours searching for bugs. That gets old very fast. And we were also very poor at estimating how long it would take to complete something, because very rarely did we actually get to do anything from start to beginning without putting out some fire. Having a process in place, though, is absolutely essential. The software that got produced in that second group wasn't even in the same league, the software written in that first group wasn't even in the same league as the software written in the second. And I think I mentioned last time, I don't remember ever working more than 40 hours a week in that second group. So the software engineering community realized that a process was very important early on. So in the early 80s, there was this organization called the Software Engineering Institute that was created at Carnegie Mellon University. And the Software Engineering Institute created this thing called the Capability Maturity Model, and that's used to gauge basically how mature an organization is with respect to building software. And the SEI, they made this claim that the quality of the software system is highly influenced by the quality of the process used to develop and maintain it. Or in other words, what they're saying is that the quality of how a project is managed will have a direct correlation on the actual quality of the software itself. And that may not be intuitive. You might think if you get a group of 15 smart people together in a room, they're going to create something good. And I can say from first-hand experience, that's not always the case. You really need to have your project managed well in order for those 15 smart people to really work to their full potential. Okay, so this idea of having a process, it actually shouldn't be, or having a process kind of influence the success of how something is completed shouldn't be new to you. Think about a student, right? So if a student's in a class and the teacher gives them kind of a semester-long project, who do you think is going to do better? A student who has no interaction with the teacher? Basically, they get the assignment on day one, and then they never interact or ask questions or do anything related to the project again until the the end of the semester when the project is due, who is that person going to do better than the person who meets once a week with the professor to make sure they're on track? Okay. Probably that second person is going to do better. If they have some process in place to actually work on and complete this project, they're going to do better, I think. And of course, I think there is a process for being a good student. So most of you are all good students, so you know this process already. But things that you should do if you're a student, I think, is you should do things like use a planner, either a calendar or some sort of either electronic or paper planner to keep track of assignments and dates where things are going to happen, right? That's kind of why we give you a syllabus in the beginning of the semester. Is we want you to be able to plan ahead or know what to expect is coming up in class. Okay. Another good thing if you're a student is you should schedule time every day, right, to do things like study and work on assignments, things like that. So when I was in school, I really thought of being in school as my job. So I would usually, from 9 to 5 every day, I would work on school and only on school. And then after 9 to 5, I did whatever I wanted. But being in school, that was my job. Another thing you should always do is see your professors when you're struggling. And maybe not even if you're struggling. If you have any question at all, you should go talk to your professor. If you need extra help, right? That's what we're here for. Actually, that's what we get paid to do, is to be available to help you. And one of the most frustrating things about being a professor is having somebody who's clearly struggling in class and they don't come and see me for help. So let's see, another thing you should do is discuss material with other students. And you should do this outside of class. Okay. You can discuss things in class, of course, but the more you're thinking about your schoolwork outside of class, I think, the better. And then, let's see, another good thing, if I was a student, I would make sure I sleep 8 hours a night. And I would play little or no video games. So to me, video games are a huge waste of time. But of course, I know not everyone is going to agree with me. Okay. So this is just a process. If you were a new student and somebody gave you this sheet of paper here and said, if you do these things, you will probably succeed. I think a lot of times new students who come to college, they really have no idea what they're supposed to be doing, and those are the ones who struggle the most. So the same thing can be said in software. If you know what you should be doing, right? If over time the people in your group have built up this experience and they've learned what works best for them, if they write that down and kind of distribute or disseminate that information, the rest of the team really is going to benefit from that. Okay, and that's the idea of having a process. So the Software Engineering Institute's capability maturity model uh, characterizes immature processes versus mature processes. So let's look at an immature process first. An immature process is ad hoc, or it's on demand. The process is improvised by whatever engineers happen to be present at the time. And I would say that that's rather chaotic. Okay? Another sign of an immature process is they have a process, but it's not rigorously followed or enforced, meaning we have this nice process manual that somebody spent a long time sort of gathering all of this knowledge, and they put it in this notebook, and this notebook is sitting on the shelf. Nobody even has read it or follows it. Okay? That's surely a sign of an immature organization. An immature process is dependent on the engineers who are currently employed. Again, if Fred happens to be sick one day and Fred likes to do code reviews, well, maybe that day we won't do a code review just because he's not there. Okay? That's really not a good sign. And from a manager's perspective, a developer should be at least somewhat replaceable, okay, like a machine or a robot. Now, of course, that's not that's not always the case, but you want to have your group not so dependent on one person that if that person happened to get hit by a bus, that the whole project would fail. So the goal is to kind of spread the knowledge out, and if somebody gets hit by a bus, or more likely finds a job somewhere else, we don't want the whole project to fail just because of that. Immature processes are riddled with cost and schedule problems. So an immature process or an immature organization actually is very poor at trying to estimate cost and schedule for things. Okay, and I could speak from experience in that first group I worked in. We were just awful. We never really knew how much time things were going to take or how much things were going to cost. So that's certainly a sign of an immature process. Another sign is functionality and quality are compromised to meet the schedule. Okay, so sometimes there are hard deadlines in life, right? We need to finish this software by maybe there's a very well-known trade show or something that we just, if we're going to do well in this project, we have to get the software ready to show at this trade show. Sometimes there are constraints like that. And if you find yourself constantly sacrificing functionality or quality to meet those schedules, that's the sign of an immature process. With an immature process, use of new technology is risky. Okay, so when I talk about new technology, that could be any tool or any maybe new programming paradigm or methodology. That these things are supposed to make your life easier. Right? Most computer-related tools are supposed to make your life easier, but in an immature process, throwing a new tool in the mix usually causes everything to slow down, basically. And a lot of times the group is better off not even attempting to use some new technology, just because they're not quite mature enough to use it in the way it's supposed to be used. And then lastly, the quality of a product is very difficult to predict in an immature process. So again, if in that first group we had 15 smart people, and if you would have guessed, you probably would have guessed, well, 15 smart people are going to make a pretty good product. And it turns out that that's not quite how it happened. Now, if we compare that to what the Software Engineering Institute calls a mature organization, or a mature process, well, a mature process is consistent with the way work is done. Okay? So meaning if the process says do steps in the order A, B, C, we actually do things in the order A, B, C. So a lot of times groups will focus on writing code first and all the documentation later. Right? So after the software is released, then we'll have plenty of time to go back and say write a requirements document or a design document. But again, that really makes no sense. The spec or the design document, those are tools to help you write the code. If you skip those steps, it doesn't really make sense to go back afterwards and um, write those documents. A mature process is well documented, so it's understood by all, and a lot of times that means there should be formal training on the process. Process should be used, so you can't just pick and choose things to do on your mood that day. However, the process should be living, meaning it can change, but only after a lot of thought and a lot of different people's experiences. So if the group has decided that, having an SQA team, yeah, it's part of the process, but it's not really buying us that much, right? The group as a whole should be able to decide, we're going to take that part out of the process. A mature process is supported by management. Okay. So oftentimes it's hard to get managers on board with this idea of process improvement. They see a process as overhead, right? If we're going to follow this process, that means the deadlines are going to get pushed out, the total costs are going to be more, because really it's more work. Okay, so a manager, if he's not a technical person and he's managing a software team, he might think your job as developers is to write code. You're not getting paid to write documents or to do things like that. But in reality, the software will be of much higher quality, so easier to read, easier to extend, easier to test, easier to maintain, that the overall cost will go down. Okay, so yes, there is an overhead cost associated with beginning to use a process, but in the long run, it pays for itself. Okay, usually many-fold, and it's hard to get a manager, a non-technical manager, to see that, okay, without them having gone through the process a few times. Let's see, a mature process, we have product and process measurement is used. So we measure things. A mature organization will measure things. How many lines of code are completed in one day? How many code reviews did we have in a given month? Okay, all of those statistics are important for managers later on, because if something's out of the norm, they'll want an explanation why. And then a mature process, of course, can make use of technology. So if a new tool is created or some new programming paradigm comes around, we can actually use it to our advantage. Okay. Yeah, there might be a little ramp-up time with the technology, but in the long run, it's going to improve our product, not slow us down. So in the capability maturity model, there are different maturity levels or well-defined plateaus on the path to becoming a mature organization. And these different levels are defined to measure basically what an organization's maturity level is. Okay. And in this SEI CMM, there's 5 levels. Okay, so throughout the rest of the course, you might hear me talk about SEI level 1 or SEI level 3 or SEI level 5. These are the 5 different plateaus that this body, the Software Engineering Institute, has decided this is a good way to characterize maturity in an organization. Okay. So the first level is the initial level, and this is basically you have no mature process. Everything is unpredictable and poorly controlled. Eventually you might have some experience where you can actually repeat tasks. Okay, so that would be level 2. Level 3 is kind of an important plateau. This is when the formal process is actually defined. So it's characterized and well understood, and people are going to follow the process. Level 4 is called quantitatively managed, and this is where the process is really measured and controlled as much as the product that we're working on. So remember, ultimately we're working on some software product, okay, but we also have to look at the process that's being used to build that product. And at level 4, we really focus on the process almost as much as the product itself. And then lastly, level 5, we call that optimizing. There we focus on process improvements and technology improvements. Okay, so how are you assigned an SCI level? Well, assessments are performed when a group wants to increase their SCI level. So typically what will happen is an independent SCI assessor will interview the engineers and the management team to decide if a group is at a certain level. The assessment team then makes a list of things required to get to the next level. So you'll have this SCI assessor. Now this is not someone necessarily from Carnegie Mellon. This can be somebody from your company who got some formal training about how to assess a team. And usually that person would not be directly related to your group, meaning they might be working, they might be a manager in a different group, and they're going to come into your group and act as this independent person. Or there are actually people you can hire to come in from outside, and they'll be independent assessors also. Okay. Basically, though, the assessor will tell you where you are, and they'll make a list of things that you need to do to get to the next level. Okay. And generally, what you want to do is get higher and higher up these plateaus. Okay, so generally it takes at least a couple years to move from one level to the next. So an assessor wants to see many examples of you successfully using your process. You can't just all of a sudden say one day, we are going to do whatever you say, and then automatically get to that level. The assessor actually wants to see you use the process usually more than one time. So that's why it can take a couple years to go from, say, level 2 to level 3. What the assessor does, or what the assessor looks for, is how you're building the software in these key process areas, or KPAs. And these are the things that need to be demonstrated before going to the next level. So once you get your SCI assessment, you'll be given a list of things that these key process areas where you need to improve before getting to the next level. And then what you can do is you work on those areas for some amount of time, and then you come back, or you have that assessor come back and reassess you at a later date. And you might go from one level to the next. Now these levels are important, these SCI levels. There are many companies and almost all government bodies won't sign a contract with a development firm unless they can demonstrate their SCI level 3 or higher. Okay, so SCI level 3, that's kind of the minimum level that you need to be to say work for the government. And the government is just a huge purchaser of software. So if you're building a software firm, it's very important that you can demonstrate your SCI level 3 or higher. Okay. And different facets of the government might have different requirements. So in the defense industry, they might require SCI level 4. Okay, if you're writing software for some weapon or something that could actually injure people, they might have even higher standards. Alright, so let's look at each of these levels in a little bit more detail. Starting with level 1. So the higher the level, the better or the more mature your organization is supposed to be. So at level 1, the product quality is completely dependent on the people who are currently employed. At level 1, the process is characterized by major problems that are really managerial in nature, not so much technical. Okay, so I think this is why most software is late, over budget, and of low quality, because a lot of time is spent putting out fires that, if perhaps you had a process, you could have anticipated these things, these bad things happening before they did. So in this case, management maybe makes schedules not based on reality. So for example, in that first group I was in, somewhere up in the management chain, I think it was my manager's manager's manager was a vice president at Motorola, and she was told she would get a really big bonus if we finished this product by whatever, October. So October 1st, if we finished the software, she was going to get, I don't know, $500,000. So she immediately said then the software or the product is going to be done before October 1st. So she didn't consult with anyone to see, is that reasonable? Is that a realistic time to finish this project? And of course it wasn't. And what happened, that led to a lot of people working very long hours, working very hard, not for their own personal gain, but because some manager is going to get some bonus somewhere. Okay. So it can be very frustrating when you have a group of good engineers who can't get anything done because they're really poorly managed. And this is what led to that massive revolt that I talked about. So within the first year of me working there, pretty much anybody who could left, and they got a job somewhere else. Because it just doesn't make sense to work in a group that something like the completion date can be determined not by reality, but by maybe somebody getting a bonus somewhere. Okay, so that's not good. Basically, at level 1, there is no process. So you have some inputs, you have this mysterious bubble here, and then maybe eventually something comes out of that. Okay. This actually can work, though, if you have a small group, if you have a small project, and you have good managers. So we know this because we've all done, homework assignments. And maybe even you've worked on some small projects and you haven't had to use any of the things we're talking about here. You had no process really, but you still got things done. So it can work, but the group has to be small, the project has to be small, and whatever managers you do have, even if that's just yourself managing what you do, you have to have good managers. Now, all the managers I had in that group 1, they actually weren't very good managers. So my direct manager was, I think I mentioned this last time, an electrical engineer, and he was a very good electrical engineer, but this was the first time he was actually asked to manage anything. And there's an old saying that people rise to their level of incompetence. And at least by the time I left, that's how I would say that's what happened to this electrical engineer. He had risen up the ranks because he was a very good electrical engineer, but when it came time to manage people, he wasn't very good. Okay, level 2 is a little bit better than level 1. So I'd say by the time I left that group, we were approaching level 2. Although we weren't formally assessed, I think if we were assessed, we would probably be at level 2. And what this means is you have some established and effective software project management. So you document and you follow some process. So early on in this group, there really was no process. We were level 1. But over time, over the 2 years that I was there, we had basically done enough where we'd gathered enough knowledge about what works in this group and what doesn't. So towards the end there, we had some idea about what our process should be. And we could in fact repeat projects that are similar to previous projects. And when I was leaving, that's exactly what we were doing. We had this two-way radio product, and we were going to expand it for the automotive industry. So a lot of people have these two-way radios in their cars, and that product was basically very similar to the one we had just finished. And things definitely would have gone a little bit smoother the second time around. Okay, so if Project X took 17,000 lines of code and 1 year with 4 engineers, and Product Y is very similar to X, you could probably plan on 4 engineers completing the similar project in about 1 year. Okay. So you're not really mature yet, but you at least have some idea of what's going on at that particular level. So some of the key process areas, some of the things used to demonstrate that you are a level 2 organization. Configuration management, that has to do with things like keeping track of the different versions of your software. Things like tracking defects. So having a place where if somebody finds a defect, we want to record that so that the defect doesn't slip through the cracks. Having a software quality assurance team. So that usually this is a team of independent engineers who look at whatever outputs the development team creates and just verifies that we're actually building the right thing and we're building it well. At level 2, you have to have some project management skills. So some manager has to sort of know what milestones to define and be able to estimate how long things are going to take and how much things are going to cost. And requirements management, again, requirements are the key to any development project. We have to make sure that we are managing our requirements. We can't let any requirement slip through the cracks. If the biggest risk to building a piece of software is building the wrong piece of software, then we absolutely need to manage our requirements. Okay, level 3. Here we control the process by defining, documenting, understanding, training, and measuring the process. Okay, so the roles in the process are well understood. All the phases are well defined. Here we document and measure everything. We review everything. So we'll talk about peer reviews later on. We use case tools. We use computer-aided software engineering tools to make sure that we can measure things accurately. Okay, some key process areas for a level 3 organization is you have an organizational process definition. And what this means is you no longer define your process on a project-by-project basis. The entire organization defines a process, and all the projects that are under that organization adhere to it. So if you move to another group in the same organization, the process will be the same. And this is how the second group I was in, the cell phone group, like I said, there were thousands of engineers and probably hundreds of different teams throughout the world, and they all followed the exact same process. That made it very easy for us to communicate, first of all, and secondly, if you wanted to, work in a different cell phone group, it'd be very easy to just switch groups because the process is the same. Okay. At level 3, we do these things called peer reviews. So last time I talked about a code review, where code review you basically you get 5 or 6 people in a room, and they literally look over every single line of code that you wrote, and if they think they have found some defect, they'll let you know about that. And they can be a little bit intimidating, but there's no better way to ensure that your software is really good than having a peer review. And another KPA for level 3 is organizational training. So the organization actually is very interested in you getting the training that you need. So this might be things like paying for you to get a master's degree or to get to take courses at college, or this might involve bringing in outside trainers to train you about a new technology or a new programming language. But at level 3, the organization really wants to make sure you have all of the skills necessary to succeed, and they're willing to pay for that training. Okay, at level 4, level 4 applies statistical process control to address the special causes of process variation. Okay. We basically continuously monitor and take action when not meeting our goals. And management has an objective basis for making decisions. They're able to predict performance with quantified, realistic bounds. Okay, so the level 4 KPA might be statistical process management. Basically, everything is measured. So how many lines of code are completed in a day? How many numbers of faults were found per 1,000 lines of code? How many hours were spent reviewing code for a code review? What were the number of faults detected per hour? All of these things are measured. And the team then, if you measure all of these for a long period of time, the team is so mature that if there's anything outside the norm, then they have to have a good reason. They have to explain, well, why is that? Why in the last month did we find a fewer number of faults per 1,000 lines of code? And the answer might be, well, a lot of this code was rework, meaning we had already had a code review and we identified many things, and the author basically rewrote the code from scratch, and they now knew what to look for. Okay, so that might be an answer. Okay, so in that second group I was in the cell phone group, we had a monthly meeting where all of these statistics were projected on a screen. So the upper management would bring in lunch or something to get everybody there together, and then my manager had to sit kind of at the head of the table, and his managers would ask him about anomalies in the data, right? So things like, why were there fewer number of faults per 1,000 lines of code? And then what my manager would do he'd go and talk to us, his team, and say, well, what's happening here? My manager needs an answer, and we need to come up with an explanation for this. Okay, so at level 4, you have all of these statistics, and you look for anything unusual about these statistics, and you're such a mature organization at that point that things tend to stay the same, right? But if something goes outside of that normal variation, then somebody has to answer for that. Okay. So at level 4, it's all about measurement. Everything is measured. Okay. Level 5 is the level where we identify and eliminate common cause of poor performance. So continual process improvement via process and technology change management. You might have heard of this continual process improvement. The idea of that, I think, was made famous by the Japanese automakers. So Japanese automakers, there's a reason why Japanese cars are typically, and this is not always the case, but typically better than, say, American cars. The Japanese automakers, they focus incredible amount of energy on the process of making a car, right? So they look at the assembly line, for example, and they try and optimize the way that the workers will actually build the car. So, for example, if there's something that's really hard to get to in the car, well, they might make a special tool so that it's a little bit easier for that auto worker to twist a bolt or do whatever. Okay, so they're constantly looking at the process of making the cars, not just the end result, not just the car itself. So some KPA, some key process areas for a level 5 organization. Well, process and technology improvement. Okay, we're always looking for ways to improve the process of creating software. And defect prevention. We look at what caused defects in the past, and we try to eliminate the cause of those defects. Okay. Now, sometimes it's hard to get things done at this level because you're so focused on adhering to the process. You have to remember you're still there to build a product. And we had a joke at Motorola. I believe there was like one software group in Motorola that was a level 5, and they were in India or something. And the joke was nobody ever saw what this group produced. So they were level 5, but they never actually produced anything because they were so focused on the process. So that probably wasn't true, but that was the joke at the time. Alright, so let's look at some of the key process areas that are required to go from the different levels. So we'll probably stop at about level 3 because that's kind of the minimum where a mature organization should be at level 3. So we'll look at the key process areas to get you to level 3. So the first one we'll talk about is configuration management. And the purpose here is to establish and maintain the integrity of the work product. A lot of times that means code throughout the software lifecycle. Okay, and this involves systematically controlling changes to items. Again, in particular, we're talking about code. And that's really important because very often we'll have multiple people working on a team, and they're all working on the exact same set of files. Okay, so when we have two or more people working on the same file, we have this problem where we need to maintain the integrity of that file throughout the life cycle. Okay, so just to give you an example, we might have Bob over here and Alice over here, and they're trying to both work on this file, let's say main.cpp. Right? So main.cpp might be the heart of the application. The whole program might be in this one file, but now we have two different people who need to work on that file. Maybe Bob is working on one feature and Alice is working on another. So what they're working on might not actually overlap, but they do have to work on the one and only copy of main.cpp. Right, so what could happen here is, first Bob could make a copy. Maybe there's a central repository where all the code is stored. So maybe Bob makes a copy of main.cpp on his local machine. And then right around the same time, maybe Alice does the same. She makes a copy. And then they both change main.cpp. So Bob puts his changes here. Alice works from her copy and she puts her changes here. Okay. So now what happens is, Bob and Alice, they have to test their code to make sure it works. But once they're pretty sure it works, they'd want to put it back in the repository. Okay. So let's say Bob just happened to go first. And then maybe a little bit later, Alice does the same thing. Okay, so we're going to store to the repo or the repository. Okay, the problem here is all of Bob's changes will be lost. Right? So they both made a copy. Bob made some changes and basically stored his changes in the central repository. But then right after there, Alice came in and wiped out all of Bob's changes with her changes. Okay. So that's bad. We want Bob to be happy. We want Bob's changes to make it into the final version here. So we'll talk a little bit more about this idea of version control. Right? So there are tools called version control tools that will help eliminate this problem. Okay. And actually I have a separate lecture planned that talks just about version control. Configuration management, though, it is about version control. It's also about defect tracking. Okay, so if somebody does find a defect, we need some way to record that defect. Configuration management also has to do with having a change request system. So if somebody decides, what we have here is not quite right, we need to make a change in the existing software. Again, we want to formally be able to track those changes, and there are tools that help us do things like that. Okay, next we have this idea of a SQA, that's an acronym for Software Quality Assurance KPA, and here the purpose is to objectively review the software work products, whether they be code or maybe design documents or specs, for adherence to policy requirements, standards, etc. Okay. And this involves this independent body, this independent group called SQA, to review work products and activities. So the SQA doesn't only examine the work product, it doesn't only look at the code, but it also looks at are the developers adhering to the process. Okay. The role of SQA is to provide an independent view, and they serve as a compliance function to management. So the managers want to make sure if we have a process, we want to make sure all of our engineers are following it. And when SQA does bring up an issue, so maybe they found that the software doesn't really do what's in the requirements, well, we have a couple options. We can make the engineers fix the product so that it adheres to the requirements, or we might have an executive decision not to adhere. So it does happen that software gets released with bugs. So sometimes, again, if there's a really important deadline that we have to meet, the manager might decide, well, we won't fix the bug now, we'll fix it in the next release. Okay. And then the other option is if SQA brings up an issue, we can maybe change the standard. If that standard really isn't buying us anything, then perhaps the standard needs to be changed. Okay, requirements management. Again, I talked about this earlier. It's really important to establish and maintain a common understanding between the customer and the development team of what the customer really wants. So the biggest risk is building the wrong system, so we certainly should document and control the customer requirements via a requirements baseline or either a document or a tool can help us do that. So all requirements must be documented. If a requirement changes, that change must be documented, and all the other documents must be updated to reflect that change. Okay, so those are the basic things to go from level 1 to level 2. To go from level 2 to level 3, the focus is a little bit different. At level 2, you focused on your individual project. Your little group has their own process. But at level 3, the emphasis shifts to the entire organization. Okay, so the entire cell phone division of Motorola, they have one process, and all of the little subgroups adhere to that process. So the organization is going to support common processes, common measurements, and they're going to provide training. Okay. So the first KPA, kind of a level 3 KPA, is this organizational process definition, where you develop and maintain a usable set of software processes to help ensure consistent performance and provide a cumulative long-term benefit. Okay? And this, again, basically involves building a set of standard software processes at the organizational level. And ideally what you'd get is the most experienced and the most knowledgeable engineers together, and they negotiate about what should this organization's process be. Another key feature for a level 3 organization is this idea of a peer review. So the purpose of a peer review, it is exactly what it sounds like. It's a bunch of your peers looking at some work product to determine if it is of sufficient quality. Okay? Or in other words, they look for defects. They look to remove defects in any software product. So we remove defects from software early and efficiently, and this involves a methodical examination of work product by peers. Okay, so this is by humans. This is a tool that is not automated and really can never be automated, because we're asking humans to use their judgment and their experience to look at somebody else's code and say, are there defects here? Could this software be any better? Now this is a relatively expensive uh, idea, or a relatively expensive thing to do, is to get 5 or 6 people in a room together, and we literally will go line for line over some either a document or a set of code, and we'll just look for defects. And if somebody sees a defect, they'll say, I have a problem with this line here, and we might have a discussion about it. So a peer review can last anywhere from a half hour to literally tens of hours worth of work. And to get 5 or 6 people in a room and spend 10 hours at a time, that's basically 60 man hours where no new work is being accomplished. Nothing new is being created. Now, let's talk a little bit about peer reviews. Peer review, again, the goal is the goal is to remove defects, but a side benefit is that the team really develops a better understanding of the work product after a review. And this, it's important to find defects early, remember. You want to find defects in the development phase rather than the maintenance phase. Right? It could cost 100 times more to fix something after the software has been released than before. Now with peer reviews, there are different statistics. Some people say you can find about 50% of your defects just by having peer reviews. But there are other people who claim that you can do much better. So anywhere to about 99% of your defects might be able to be found in a peer review, as opposed to letting the software be released with bugs in it and then have the customer find those bugs for you. So I would guess it's somewhere in between there. Even if you have a peer review, that software still might have some bugs in it, but you find a lot of bugs. You find a lot of problems having a peer review. Basically, the way a peer review works is, first, everybody needs training in how to do a peer review. And I remember when I joined that second group, that was one of the first training sessions that we had, was how to do an actual peer review. Then we give the material. The author will give the material to everyone else in the peer review, the material in advance. So you get a couple days to look at the code or the document. Then roles are assigned. We'll talk about the different roles in a peer review. We set time limits, so we say we're going to meet in 2 days, and we're going to limit the amount of time we meet to like 2 hours. And then everything that we find in that peer review, we're going to track that. So we have to record it somewhere. And then we'll collect and analyze the data for the peer reviews. This is part of the data that we looked at monthly in our big sort of statistic review. Okay. So the goal of a peer review is to find faults. Okay. Not fix them. Okay. So if a lot of times a peer review will involve code, and I might be responsible for writing a couple hundred lines of code that relate to some feature. Okay. So I would do that work. I would test the code to get it to the point where I thought it was complete. Okay. But then I'd schedule a peer review of my code. And like I said, like 5 or 6 people would gather in a room, and your code is literally read aloud in front of all 5 or 6 people. And if somebody has a problem with something that's being read, they'll say, well, I think this is not right, and a discussion may ensue. Okay, so it can be a little intimidating just because you have all of these people looking at every single line of code that you wrote. But the idea is to find faults, not try and fix them. So in a peer review, we don't write any code. We don't write any new code. We just say, line 10 looks a little funny. I don't think that's going to do quite what you think it is going to do. And then it's up to the author to go after the review and fix that. Okay. Peer reviews tend to you want to limit the time that a peer review takes. So there's a little graph here. As time goes by, the quality of the comments goes down. Okay, so if you were to schedule, say, an 8-hour peer review, after a couple hours, you're going to be so tired or so bored of just sitting and listening to this document be read, you're probably not going to make very good comments. So we like to keep it to like a 2-hour max for a peer review. Now what that means is if we have a lot of code and we can't fit it all in 2 hours, then we break it up into chunks. So maybe one day we'll have a 2-hour peer review on the first half, and then maybe a day later or a couple days later we'll have another 2-hour session where we look at the other half of the code. And there's basically 5 different phases of a peer review. Okay, that we'll talk about here. First is the overview phase. Okay, so what happens is the author of the code will usually send an email to the other members of the peer group with the document that's going to be reviewed. Okay, so if it's code, it might be a file that lists all the code that's going to be looked at in the review. And they might say, we're only really reviewing lines 100 to 200, so you can ignore the first 100 lines of code. We're only reviewing the second 100. Okay. Next comes the preparation phase, and this is really the most important phase. This is where each of the members of the group, they usually print out their copy of the material, and then they read it line by line. And what I like to do is get literally a red marker, and anything that I think is a defect, anything that I think is wrong in the code, or anything I don't quite understand, or anything that I think will be hard for someone else to read later, I'll mark, and I'll mark that code, and I'll write a little note next to it. And then what's going to happen later on is when the code is being read aloud, I'm looking at my copy, my marked up copy as a reviewer, and then I have to ask the question, well, this line here looks a little funny, and I'll ask the author, can you explain what this code is doing? Or I might say, I don't think that code actually does what you think it's going to do. Can you explain your algorithm? And then usually we have some kind of discussion. So everyone is responsible, all the people in the peer review are responsible for doing this preparation. And what they have to do is they should also track the time spent preparing for the review. So if you don't spend enough time, if you were so busy and you just didn't have time to fully look at the material, well, then the peer review can be delayed. Okay, so you don't want to be reading the code for the first time in the actual peer review. You want to make sure you can dedicate enough time to look at the material in advance. And again, this is another reason why this is a really somewhat expensive tool, is because not only do you have to have a couple hours to sit in the actual meeting, you might also need a couple hours just to review the material in preparation for the review. So you can easily, spend half a day, having these 5 or 6 people spend half a day doing nothing more than reviewing and then actually sitting in the actual meeting. Okay, the next step is the actual inspection. This is where the 5 or 6 people meet together in a room. they close the door, they and then they go over this line by line. Okay, so we'll talk about the roles in a peer review in a second, but one of the roles is that of a reader. So that person will, and this is usually not the author, they will read the code one line at a time from top to bottom. And then if any of the other reviewers has something to say, they'll interrupt the reader and maybe ask a question or ask for clarification. And that's basically how it goes. If something is determined to be a defect, it will be recorded. And the review is over once we finish all the material that the author wanted us to review. And again, whenever you have a peer review, there are going to be defects found. So no matter how good you think you are, there's usually someone is going to find something wrong with your code, and it's really important you don't take it personally. You will have the opportunity to sit in on these peer reviews yourself. So you shouldn't really take things personally. You can actually learn a great deal about good code from sitting in on these peer reviews. So if there's somebody you admire, somebody's code you admire, if you sit down in a peer review, you can actually learn quite a bit just from looking at their code. Okay. In the inspection, though, of course, we don't fix faults, we just identify them. The author is responsible for fixing the code in the rework phase. So this happens after the inspection. After the inspection, the author will have a list of all the defects in the code, and then the author goes and basically fixes those things. Okay. And then lastly, we have what's called the follow-up. Okay. So if we had this list of things that were wrong defects, we want to make sure the author actually went and fixed each and every one of those defects. So that there's somebody in charge, that person's called the moderator, and he will basically look at the list of defects, he'll look at the old code, and he'll look at the new code to make sure that all of those defects have been fixed. And if the follow-up requires that the author really throw out a majority of the code and rewrite it from scratch, well, then what should happen is we should basically re-inspect that code. However, if the author can just fix up a few minor things here and there, we don't need to have an entire review again. We can have the moderator can sort of make that decision about whether we need to completely review the work or not. Okay, so there are actually different roles that people play in a review. So the first is the author. This is the person who writes the code or whatever document we're reviewing. And the author, typically his job in the actual inspection is to basically be there to answer questions. Okay, so they don't take a really active role. They're just there to answer questions and clear up anything that needs to be cleared up. There's another person's job in a code review called a moderator. Okay, and the moderator is usually a highly skilled lead developer, and they are the one who's responsible for ensuring that all the defects are actually fixed. So like I said, they manually look at the log of defects and they look at the updated code. The moderator also asks questions and really drives the discussion of if somebody says, I think this is a defect, the moderator might actually drive a discussion about why that person thinks we have a defect, and ultimately they are the ones who decide whether something is a defect or not. We have another role. We have the role of the reader. And like I said, there's literally somebody who sits in the room and reads the document from top to bottom. Okay? And then, of course, they're interrupted quite frequently, and that's fine. The reader will stop, and the discussion will happen, and the moderator will either decide that's a defect or it's not. and then he'll go back to reading. There's another role. This is why you need about at least 4 or 5 people. Typically, we like each person to do something different. We don't want someone to be, for example, the moderator, the reader, and the recorder. That's too many responsibilities there, so we want to spread that out among at least a couple people here. The recorder records all the defects. Okay, so either with pen and paper, or there are software tools that can help you record defects. So they have to be able to sort of summarize or describe the defect, so that the author will know recall what was being talked about in the review. Okay. The recorder also records things like how long did each reviewer spend preparing for the review, things like that. Again, that in a really mature process, we measure as much as possible. So we measure things like time spent preparing for the review. If on average this group averages maybe 30 minutes per 100 lines of code, if for some reason some code review is outside those norms, somebody's going to have to answer to that. Why is this code review, did it take an hour per 100 lines? There might be a good reason for that, there might not, but we want to have the management team sort of always be aware of the statistics that are involved with a review. Okay, and then lastly, we may have one or more reviewers who aren't doing any of these roles, meaning their job is to just look at their marked up copy, and if they find an issue with something, okay, they're going to interrupt the reader, and discussion is going to ensue. Okay, and then lastly, we will talk about organizational training as a key process area. And the purpose here is to develop skills and knowledge so engineers can perform their roles effectively and efficiently. And this involves identifying training needs for an organization, for a project, for an individual, and developing or procuring that training to address these needs. So training may be formal or informal instruction. Like I said, it may involve paying for higher education, may involve paying for you to go take classes somewhere. Or at Motorola, actually, Motorola had their own internal training group that they called Motorola University. And a lot of the training was actually handled by Motorola employees. Another way to get this training is to have mentors. So mentors and on-the-job training can be very effective when implemented correctly. So at this point, I always like to ask, should you work at a level 1 organization? And my answer really would be no. Having done this, having gone through this process, I learned more bad things than I learned good. Now these things happen to be, they're actually great for me now when I teach about software engineering, because I learned all of the things that you shouldn't do. And I got to see the results of making really bad decisions. So in that sense, it was actually pretty good. But I would be very worried if the team I worked on was not a very mature team. So unless the team and the projects are very small and the managers are very good, I don't think you'll really grow at a SEI Level 1 organization. You'll learn very bad habits, and you'll learn how to put out fires maybe, but you won't really learn how to become a good engineer. So once you start going out there and looking for a software engineering job, there's some questions I think you should ask. Right? So when you go on an interview, yeah, they're going to ask you questions, but you should ask them questions too about the organization you're about to join. And one of the first should be, what is your SEI level? Okay. Um, so they may or may not know what that is. So there are these different standards. SEI. There's another one called ISO. Um, Basically, though, you want to get an idea of how mature they are. If if you ask them, a question like, "What's your SEI level?" and they have absolutely no idea what you're talking about, and you explain to them it's a way to measure maturity, and they don't sound like they buy into that idea, I think you might want to move on. Okay. If they say they're level 2 but they're working towards level 3, I think it might be worth staying. Okay. Another question you can ask right away is, what training am I going to need? And you can ask, well, how's it going to be delivered? If they say, oh, we'll teach you on the job, don't worry, that's a red flag to me. You could ask if they have a mentoring program, and ideally the organization will have some sub-organization dedicated to training. So like I mentioned at Motorola, they had this Motorola University. And there was actually a requirement at Motorola. If you were an employee, you had to spend 40 hours a year taking some kind of outside training. Okay. And this applied to all employees, whether you're in the factory on the line or you're a software engineer. So this is how dedicated they were to training. They were willing to basically give up a week of your time a year so that you could go learn something new, and then hopefully you'll come back and apply what you've learned to your job. But that's a pretty impressive thing that they're doing there. They're giving up 1 week a year of you being productive so that you can go learn something new. To me, that's a really good sign. Another question you might ask on a job interview is, you should ask for the structure of the organization. So the people you interview with will not always be the people that you're going to end up working with. So find out who you're going to report to and who you'll actually be working with, and make sure you talk to those people. You don't want to get on the job and finally realize that all those smart people you talk to in the interview, you're not going to work with any of them. You're going to work with this completely different group of people that you don't know anything about. So those are just a few questions you could ask on a job interview.